It's problem 1161 on page 658. It says a particle moves in a straight line with a constant acceleration of negative 4 feet per second squared for 6 seconds, 0 acceleration for the next 4 seconds, and a constant acceleration of 4 feet per second squared for the next 4 seconds. Knowing that the particle starts from the origin and that its velocity is negative 8 feet per second during the 0 acceleration time interval, construct the velocity and position curves versus time for 0 to 14 seconds and determine the position and the velocity of the particle and the total distance traveled when time equals 14 seconds. So let me copy the graph that they gave us. This is acceleration in feet per second squared. There's our time axis in seconds. And initially, it's negative 4 feet per second, 6 seconds, 0 acceleration to 10 seconds, and then a positive 4 feet per second until we get to 14 seconds. So basically, if we just had the velocity and position curves, we could solve this problem. Now we know that the velocity during this section, just for reference, the velocity is negative 8 feet per second. How do you think we should start to solve this problem? How should we make the velocity, what I wish it wasn't there, but that's okay. How should we make the velocity versus time graph? How about if we begin with something we know? For example, we know we've got negative 8 feet per second during this interval. Right? So if we put a line down here at negative 8 feet per second, we know at least we've got part of the curve, right? What do you know about acceleration? How does acceleration affect velocity? Well, that's the definition of it, right? If it's a positive acceleration, it adds positive velocity. If it's a negative acceleration, it takes away from positive velocity, or adds to negative velocity. Right now we've got a negative velocity, so what is this positive acceleration going to do? It's going to increase the velocity in the positive direction, or you could say it's going to take away from the negative velocity. Now, how much does it add? Well, we've got 4 seconds worth times 4, so this is an area of 16. What that means is the change in velocity is going to be 16 feet per second. We're at negative 8. That means we'll end up at positive 8 feet per second with a linear change between. How do I know it's linear? Because this is a horizontal line. The amount of change in velocity added every second is the amount, or is the same, excuse me. So, for example, while this is at 10 and this is at 14 seconds, where this crosses must be at 12 seconds. Okay. What about on the other side? Well, the other side is negative acceleration. In other words, it is acceleration that makes the particle move faster in the negative direction. So it ends up here at negative 8. Where did it start? Well, it must have been slowing the particle down, or moving the particle in more the negative, well, not moving it, but causing it to accelerate in the negative direction. And it's, what, 6 times 4, 24? So my graph is not to scale, this is going to be awful, but I need a change of 24, right? So let's say negative 8, 16, so this would be 16 feet per second. So my math is right, that's a change in velocity of 24 feet per second. Okay? Any questions about all this? All right. So what about the position graph? I wish I could put the position graph. Well, you know what? Actually, maybe I can. You know why I don't need the acceleration graph anymore for the sake of position? It's because the position can be derived from the velocity graph. Okay, so this was 14 seconds. What was that, 6 seconds, I think, and this was 10. Okay. Some reference marks up here so we know where we're at. There's 6, 10, 14. Now, did they tell us anything about position? Let's see. The particle starts from the origin. is one thing they mentioned. So if the particle starts from the origin, then at time 0, it's at x equal to 0. Now, which way does the particle begin to move? Well, the velocity is a positive velocity, isn't it? So it's moving up. So really what I need is all of this area in here. Because again, position is just going to be the interval of velocity over time. That's all it is. So this is a height of 24 and a width of 6. So I need 6 times 24 over 2, so that's 3 times 24. 48 and 24 are what, 68, 72? Am I thinking right? So we know we're going to end up at a position of 72 feet. What does the curve look like that connects those 2 points?
Parabolic.
It's parabolic. Will it be like that or like that? Concave up or concave down?
Concave down.
Okay. How many people vote for concave down? How many people vote for concave up? Good, we learned something. It's a lot like the work we did with shared moment diagrams in 211. Right? Okay, now here's another question for you. At 6 seconds, what's happening? Is the position staying the same, increasing, or decreasing?
Decrease.
It's decreasing, that's right. So it's going to start moving down. Now, is it correct for me to have my maximum point right here? Should my maximum have occurred before then?
That's what I was saying, because it crosses the...
It does cross. In fact, it crosses here. So in other words, the velocity is in the positive direction to here, but in the negative direction here.
Yep.
So I've made a mistake. I should have had a maximum somewhere here. Let me continue this up. And come back down to that point, right? Okay. Because this will give me the maximum position, because that's where we achieve zero velocity. Okay. Now, going back to this point though, as we move on, we've got a negative velocity, so we're going to be losing position. Should I make a line, I don't know, something like that? Is that right or not? What's wrong with what I've just done? Well, notice that the magnitude on this graph represents the slope on that graph. The magnitude here is -8 on this side of 6 and on that side of 6. So what I should have done is I should have made a line that comes off tangent, you see? Because it would have the same slope on this side as it had on that side. And by the way, will this, let me think for just a second. Yeah. So our velocity is negative, so we're just going to keep losing position. So this is just a straight line, isn't it? Now, unfortunately, my scale is awful, and I'm afraid that angle is far too much. Let me not emphasize it quite so much. That's supposed to be concave down, so it should come off something more like this. So how much position change is there? Well, that's what we discovered here. To 6 seconds, there's a position change of 72. But what's this position?
I think you're calculating that wrong.
Did I do that wrong? You're right, you're right.
Yeah,
I'm not thinking right. Let's take care of this area first, because that would be positive displacement.
You have to calculate a small triangle for the
Yeah,
negative.
you're right. So we need this area.
No, you just need the positive part of that.
You're right.
Yes. So just the upper triangle,
Yeah,
and then the smaller little triangle for the negative.
Yeah.
yeah, you're right. Thank you. We just need the area under the curve. So let's fix that. So that would be what, 16 times, well, we've got to figure out where that crosses. That should cross at 4 seconds, if I'm thinking right. Right, because we'd have a third, a third, and a third, a third, a third, and a third. So if that crosses at 4 seconds, then that'd be what, 4 16s, 64?
Yeah,
So I should have hit a position of 64 at maximum. And then we'd have this area, which is what, 2 times
Is it
8?
6?
Oh, 32.
24.
You're right, 32. I'm thinking 16 times 4 is 64, but I need to divide by 2 because it's a triangle, so 32. We'll get it eventually. Keep me honest, guys. And then this triangle would be 2 times 8, well, 1 times 8, 8. So it'd move down by 8. So this
32 is the maximum.
32 is the maximum. Move down by 8, that would be what, 24?
24.
Yeah, there we
Which
go.
makes sense, because then you can put the zero.
I'm lost. I had 24 for the velocity top number. You
For the
erased all the
velocity?
stuff. Yeah, I've got
Okay.
24 up there.
That's because we were, how did I come up with that? That was from the acceleration, right? I erased that acceleration graph.
Yeah,
And so that was a change of 24, right?
from
Well,
negative
we
8.
know that the velocity has to end up at -8. And we knew that the acceleration caused a change of 24 feet per second. That's why we came up here to 16, not up to 24. Does that make sense?
Sure.
Unfortunately, I've erased the acceleration graph. But it's a delta, it's a difference. So notice from 16 down to -8 is a delta of 24. Okay? All right. So then what we need is, and actually this is the wrong area.
Yeah, it's the top part of that.
This area here, but it's the same area. So that's okay. Please correct me if I'm
I
wrong.
was
Maybe we
gonna say
should
it's the
start
same
over.
value, and I was like, I'm not gonna.
No, please do correct me. Do correct me. Because the next thing to do is to calculate this area here. And that area is 4 times 8, 16, 32, right?
2, yeah.
So a change of 32. So we were here at 24. We'll end up at, well, we need a delta of 32. So if that's 24, we'll end up, what, 8 below? No, 6 below. Yeah, no, 8 below. 8 below. So we'll end up at a position of -8 feet. I guess the scale's not too bad, that looks reasonable. And then, we're going to continue to move in the negative direction, right? But now we're slowing down. In other words, we're going to have something that's concave up like this. So we need this area. It should be the same as the other side, I think, if this slope is the same. Not sure that it is. Oh, well, we've got a delta of 2 like we had over here, and a change in height the same, so it is the same area. So that difference was what, 8?
8, yeah.
Yeah, so
Negative
8.
16.
So, yeah, we would be at -16. Now, wait a second, though. Where does this cross? It must cross at 9 seconds, I think. Anyway, so we'd end up at -16 right about, that was at 12 seconds, right about there. And then, we just need the area beneath this curve. So that's 2 times 8 over 2, again, just 8. So we end up right there, if I'm thinking right. Make sense to everybody? So we end up at a position of -8 feet. That's the final position. What did they ask?
Determine the position of velocity of the particle when the total distance traveled when t equals 14 seconds.
So the velocity is 8 feet per second. That's the final velocity in the positive direction. The position at that time is -8 feet. And I thought, they wanted the total distance traveled though, so not the final position, but the total distance. That's a different thing. The total distance traveled would be from here out to 32, plus the 32 feet back, that's 64, plus 16 feet. Let me keep track of this. What did I say? 32 plus 32, so going out, coming back, that's that distance. And then plus 16 feet, and then coming back 8 more feet. So 64 plus, what did I say, 24. So that's what, 88? I traveled 88 feet or so? Well, exactly 88 feet. Any other mistakes I made along the way? Possibly. I haven't seen them. If so, it's long gone now, isn't it? All right. Any questions? Yeah, can we start over?